Hello everyone, in this video I am going to cover what is covariance and correlation. Covariance is defined as dependency between any two random variables as compared to their mean. Let's say x and y are two random variables, then covariance of x and y is defined as expected value of x minus expected value of x times y minus expected value of y. Alternatively, you can also write x minus x bar times y minus y bar ka expected value, right? Now let's try to expand this expression and get something easier version of this expression. When we expand this expression, you will get four term xy minus x bar y minus xy bar plus x bar y bar. We all know that whichever the term like x bar, y bar and these terms are constant, right? And we also know that linearity of expectation. So it will be equal to expected value of xy minus expected value of x bar y minus expected value of xy bar plus expected value of x bar y bar. Here x bar, since x bar is constant, x bar will come outside and it will be equal to expected value of y minus y bar will come out expected value of x times, and since both x like x bar and y bar is constant, so expected value of constant is equals to constant. Now expected value of y is equals to y bar and expected value of x is x bar. When you write, it will be equal to expected value of x times y minus x bar y bar minus y bar x bar plus x bar y bar. You can cut one x bar y bar. We are remaining with expected value of xy minus y bar times x bar, which can be written as covariance of xy equals to expected value of xy minus expected value of x times expected value of y. This expression is very important and can be utilized at every place in financial domain. Wherever we have to calculate the covariance between any two random variable or any two stocks. Let's see intuitively what covariance says. If random variable have positive covariance, means if one variable is moving to above the mean, it also means that another variable is also moving above the mean, and if it is moving below the mean, it is also equal to moving below the mean. Similarly, when covariance is negative, it means in opposite direction, and when covariance is 0, it means there is no any systematic co-movement between these two variables. There is a special case when y is equals to x. When y is equals to x, so it will be covariance of x times x is equals to expected value of x square minus expected value of x ka whole square. So it is equal to variance of x. Now let's define what is correlation of x and y. Correlation is the normalized covariance between two random variables and measure the strength as well as direction of their linear relationship. I will explain you what this linear relationship mean, but before that let me define correlation of x and y is equals to covariance of xy divided by standard deviation of x times standard deviation of y. Now let's put an important concept here. Let's say x is random variable, uniform random variable, and y is general random variable which can be defined as y equals to x square. Then what will be the correlation between these x and y? Will it be 0 or non-zero? Let's see how we can establish the correlation between these two random variables. Covariance between x and y is equals to expected value of xy minus expected value of x times expected value of y. Here we know that expected value of x into y, which is equals to x times x square, because y is equals to x square. So it will be equal to covariance of xy is equals to expected value of x cube minus expected value of x times expected value of x square. For uniform random variable ranging from like -1 to 1, expected value of x and expected value of x cube is equals to 0. If you don't know this property of uniform random variable, then you can see the previous video in the same playlist. This will be 0 and this will be 0, hence covariance will be equals to 0. In this way we can say that covariance between x and y is 0, and hence correlation will be equals to covariance by sigma x times sigma y. Since covariance is 0, hence correlation will also be 0. Here you can see that there is a relation between x and y which was quadratic relationship, but the correlation between these two random variables is 0, because correlation only measures the linear relationship, not anything else. So non-zero correlation means that there is a linear relationship between the two random variables. And if there is zero correlation, it means there is no linear relationship, but it can be possible that the other relationship exists like quadratic here. Before ending this video, let me ask you a question. Let's say this y and x are two variable. There is one z2 z1 and z2 derived random variable from this x random variable, and the PDF of z1 and z2 is given. What will be the correlation between z1 and z2? Thank you.